So looking at the practice test, number 1, how many students are shorter than 70 inches? So 70 inches starts right here. So shorter than 70 is everything on the left side. So since this bar is 6 high, and this one is 4, and this one is 5, you would just add all of these together. So 6 plus 4 plus 5 is 15. So how many students are taller than 64? 64 is right here. Okay, 60 to 64. And so taller would be on the right side. So this is 2 and this is 1. So 6 plus 2 plus 1 would make that 9. So for this question, are there an equal number of students who are less than 65 inches? So we need to figure out how many students are less than 65. Less than 65, again 65 is right here, because this is 65 to 69. Less than 65 would be 4 plus 5, which is 9. And taller than 69 on the right side, again here 69 would be 2 plus 1 is 3. Since they are not equal, your answer is no. A former professional golfer is the teacher of a class. There are 10 golfers taking the class. At the end of the class, everyone, including the teacher, plays an 18-hole round of golf. His score is 30 strokes less than the best golfer in the class. 30 strokes less. So because his score is so much better than the others, he is considered to be an outlier. So it says, which measure of central tendency is most affected? And that means the answer is the mean. Because his score will greatly throw off the average score of the golfers. So for number 5, what percent of the values are between 50 and 80? Remember, each of these is 25% of the data. No matter how big or small it is, they all represent 25%. So between 50 and 80, there is 2 spots. So 25 plus 25 is 50%. The interquartile range of the data is Q3 minus Q1. So remember, in a box and whisker plot, the first number is the min. This is Q1. This is Q2. This is Q3. And this is the max. So the interquartile range is basically just the right side of the box minus the left side of the box. So that's 80 minus 50 for 30. Again, interquartile range means the right side of the box minus the left side of the box. Turning the page, what type of correlation is represented by the data in the scatter plots? So since the dots are increasing, this is considered to be a positive correlation. And since these dots in general are decreasing, this would be a negative correlation. So for number 9, which correlation coefficient is the most accurate for a trend line in problem 8? So that would be this one. Since they're going down, that means it must be negative. So right away we can cross out B and we can cross out D. Okay. We can also tell that it's negative, which means we're closer to a straight line than we are to no correlation. So this would be negative 0.7. Remember, 0.7 is bigger than 0.07. So it's closer to 1. For this one, what is the marginal frequency of total students who prefer sports cars? So sports cars, when we say marginal, we are talking about the total. Marginal means total. So sports cars, we go all the way down. Sports cars, the total amount of sports cars is 84. So this answer is 84. So this is joint relative. That word relative right there is very important. That means we're going to be dividing. So joint relative of males who prefer SUVs. So male SUV, there are 21 males who prefer SUVs, 21 males. And there are a total of 240 overall people. So 21 out of 240, we're going to divide that. And this comes out to 0.0875, which would round. It says round to the nearest hundredth, which is the second decimal place. So this would round to 0.09. This next one says, what is the conditional relative frequency that a student is female given the student prefers sports cars? So since this is conditional, we're looking for a main word, given. Given is the important word. So we need to divide by whatever comes after the word given. So after the word given is sports cars. So there are, if we cover everything up, there are 84 total sports cars. So 84 is on the bottom. Of the 84 sports cars, how many of them are female? And that would be 45. So 45. So again, we're going to divide 45 divided by 84 for an answer of 0.54 after we round it. That is our conditional frequency. Sports cars comes after the word given. There are 84 total sports cars. 45 of them are female. And we get the female from this part of the problem. So underneath it, it says, determine if there is a positive or negative correlation, and if so, is it causal? So the number of hours spent studying for your Math 1 Unit 6 test and your test score. That would be a positive correlation. As you spend more time studying, your test score should go up. One goes up, the other goes up. That's positive. And that's a causal relationship, because studying causes you to do better. Next, the number of center hits, those are called bullseyes, in a darts game, and the distance from the dartboard. So as you increase the distance from the board, as you get further away, that means you should be hitting the board less often. So as the distance increases, the number of hits you get decreases. That is a negative correlation. And that's because when you're farther away from something, it becomes much more difficult to hit something. So that is causal. the number of letters in the city that you live, and the average annual rainfall. So let's think of, what are some cities I could think of that will work? I'm trying to think of cities in California, but that's not really happening right now. Okay. So Los Banos is in California, and Orlando is in Florida. They each have, oh man, I can't count. I definitely can't count. Oh, we'll just change this one to Seattle. Now, Seattle has 7 letters in the name. Orlando has 7 letters in the name. Does that mean that they're going to get the same amount of rainfall? And that answer is no. So therefore, there is no correlation. Just because you live in Bakersfield, which has more letters in the name, that will not cause you to have more rain. So the equation blah models the data for average height of boys age 5 to 13. Using the equation, how tall do you estimate an average 12-year-old boy to be? So we write y equals 2.3, and since we're trying to find how tall a 12-year-old is, we are going to plug that into x. So times 12 plus 33. And all you got to do is plug that into the calculator. And we get 60.6 inches. A little bit taller than 5 foot. The next ones, they're asking you, does the residual plot suggest a linear model may be the best fit for your data? So this one would be yes. There is no U shape. This one would also be yes. There is no U shape. And this one, yes, it does suggest it. Don't try to look at this sideways. It doesn't matter. You keep the graph as it is. This isn't a U over here. So this is yes, there is no U shape. But this answer would be a no. There is a U shape. So basically, if you see a U, it is not a good fit. So right here, we have a whole bunch of numbers. We're going to put them in order. So the first one is a 1. And then we have a 7. 1, 2, 3 8s. 2 9s, and a 10. So to construct the line plot, you're going to start at the number 1, and you must include every number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Every number must be included, because it's important to report that no numbers between 1 and 7 have been reached. So for the number 1, we're going to put 1x or a dot. Your call. You put whatever you want for your thing, but there needs to be something over the 1. There's 1 7, so you put one thing over the 7. There are 3 8s, 2 9s, and 110. So to find the mean we're going to add all the numbers together and then divide by how many scores there are. So 1 plus 7 is 8, 16, 24, 32. 32 plus 9 is 41. 41 plus 9 is 50. 50 plus 10 is 60. So the mean is equal to 60 divided by the total amount of numbers. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers. And 60 divided by 8 is 7.5. To find the median, you take the middle number. So 1 and 10 match up, 7 and 9 match up, 8 and 9. There are 2 middle numbers. If you have 2 middle numbers, you're supposed to add them and divide by 2. And 16 divided by 2 is just 8. Now I know what you're thinking. Branghetto, why did you do that? They're both just 8. Well, yeah, if they're the same number, you can just pick them. But if they're different numbers, you need to add them and divide by 2. So it's a good habit to get into. Mode is the number that shows up the most, and that's where the dot plot helps. 8 has the most amount of x's, so the mode is 8. And your range is the biggest number minus the smallest number, which is 9. So when they ask which measure of central tendency best describes the data, you would use the median. Okay. Since there is an outlier, the outlier would affect the mean of this problem. Because there is an outlier which throws off the mean. So because there is an outlier, the mean is affected, so you should use the median instead. See, if you were to throw the 1 out of there and not include the 1, you would have 8 is the middle number, so the median wouldn't change. But if you were to do a new average, 15, 23, 31, 40, 49, 59, 59 divided by 1, 2, 3, 4, 5, 6, 7, you would end up with like an 8.43. Uh-oh. I think it should still be okay. I don't know if you guys can see it, but my projector went out for a bit. So that mean is almost 1 bigger than our mean down here. Like 10 more %. Okay? So you should use the median instead. Okay. For 24, the drama club sold 435 tickets. So you're going to write 435 tickets. That's the total amount of tickets they showed. It says, of 186 sold for matinee. So for matinee, you write 186. Of those tickets, 74 were adults. Of the 249 sold for evening, so 249 were for evening, 191 were student tickets. So 191 were student tickets. Okay, and we need to construct the rest of the table. So to find the missing students, all we need to do is subtract 186 minus 74, and that would be 112. For this one, you subtract 249 minus 191, and you would end up with 58. So to come up with our new total, 74 plus 58 together makes 132. And 112 plus 191 would give us 303. So underneath right here where it says predicted value, all you got to do is take the x and plug it into the residual equation. So this is negative 0.3 times 2 plus 8.7. So you can just plug that into a calculator. Negative 0.3 times 2 plus 8.7. And that comes out to 8.1. Negative 0.3 times 4 now, because I need to plug in an x value of 4. Plug it into a calculator and you get 7.5. Negative 0.3 times 6 plus 8.7. This is 6.9. And negative 0.3 times 8 plus 8.7 comes out to a 6.3. So these right here are all of your predicted values. That's what we predict would happen. To find the residual, you do y minus y hat. So this is 6 minus 8.1, which is negative 2.1. That's our residual. Over here we've got 16 minus 7.5, which is 8.5. 27 minus 6.9, and that comes out to a 20.1. And 24 minus 6.3 comes out to 17.7. So these numbers here are all of my residual values. Let you take that in real quick. Okay. Underneath right here. Okay, so to make a scatter plot of the data, all you have to do is graph. So I'm going to count these guys over here by ones. Let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So maybe if I count by 12s, that might be good. 10s might be good too. We'll do 10. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm just counting the bottoms by 1, and I'm going to count these guys by 10s. 10, 20, 30, 40, 50, 60, 70, 80. You don't need to write every single number. Every other one is fine. You just got to make sure you can include all of your points. So I counted mine by 10s. You might count them by 12s. You might be able to count them by 9s. Maybe by 8s. Maybe not by 8s. Not quite sure. But you got to count by a number bigger than 1 for sure to fit 136. So we got to make a scatter plot. So 1, 30. Right 1, up 30, put a dot. There's our first point. Next one is right 2, up 55. So 55 is in the middle of 50 and 60. We'll go right there. 3, 80. Right 3, up to 80. 4, 112. You go a little bit above 110. It's not going to be exact, but that's okay. And 5, 136, just underneath the 140. So to draw our line of best fit, let's just put a line through the dots. So we made a scatter plot and we drew a line of best fit. That was number 26 and 27. Okay. All you had to do was just graph the points. So for this part underneath, write an equation for the line of best fit using the following points, 2, blank. So 2 matches with 55, so we're going to put 55 right there. And 5, blank, 136. If that's all you did for this problem, you're way off. Okay. So we need to write an equation. That's what they're asking us for. We need an equation. A y equals mx plus b equation. So we're going to call this x1, y1, x2, y2. And the first thing that we need to find is the slope. I'm going to zoom in here because I need to write very small. Our slope, m, is equal to y2 minus y1 over x2 minus x1. That's the slope formula. You need to have that memorized. Look at it, absorb it, process it. Okay, it's in your brain now. So y2 is 136 minus y1 of 55 over x2 of 5 minus x1 of 2. 136 minus 55 is 81, and 5 minus 2 is 3. So 81 divided by 3, that gives you an answer of 27. That is your slope, not your answer, just your slope. They asked us to write an equation. This is a number. You're not done. So we need y equals mx plus b. That's what I need left. Y can be either 55 or 136. You get to pick. I'm going to pick 55. M is our slope. We found our slope was 27. X is our x value, which we found to be 2. because if we use 55, we have to use 2. If you use 136, you must use 5 plus b. So 55 is equal to 27 times 2 is 54 plus b. And subtract 54 from both sides to get 1 is equal to b. Okay. So instead of y, it was 55. M was 27 from here. X was 2, because that's 55 and 2. They went together. 27 times 2 is 54. And the opposite of a positive 54 is minus 54 on both sides. So b equals 1. Okay. So since b equals 1, our final equation is y equals 27x plus 1. That is our equation. Positive, negative, no correlation. Since the dots are going up, this is considered to be a positive correlation. And how long would you expect an 8-month panda to be? So it's going to be bigger than 136, hopefully. So we're going to write y is equal to 27 times 8 plus 1. And you just basically put that in the calculator. 27 times 8 is 216. And 216 plus 1 is 217 inches. So again, we found the slope using the slope formula. We plugged the slope and a point in to find our b value. That gave us our equation. We use this equation to predict the size of an 8-month panda. Our last problem. The linear regression equation is this. So this says find the predicted value when x equals 6. So all you got to do is plug the number in for x. Negative 2.4 times 6 plus 16.5. Negative 2.4 times 6 plus 16.5. I get an answer of 2.1. It says find the residual value. So the actual value minus the predicted value. It says the actual value of y is 3. So instead of y, you put 3. We solved for y hat and got 2.1. 3 minus 2.1 is 0.9. And those are your 2 answers for the last problems on your practice test. Okay, best of luck. I'll see you guys when I return on Friday. Good luck and have a wonderful day.